Okay. So, is the screen visible to you all? Yes. Is it visible?
Yes, yes, ma'am.
Okay. Yes. Yeah. Okay. So, I hope you all are till now familiar with what is Hadoop and how Hadoop handles the storage space, storage of the data, and also through MapReduce how we basically do the processing, right? Just a second. Hmm. Yeah. So all of you are aware of HDFS and MapReduce? Everyone? Yes or no?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay. Okay. So you all have done executed the HDFS query, HDFS commands and the MapReduce program, right? So in that we have seen that how we basically deal with data in MapReduce. We basically work on in a key value pair domain. Okay. In key value format, we basically do, right? So there were some problems with that approach. Okay, so what were the problems? Okay, so first of all, the thing was that any kind of problem, let's say you have some data with respect to stock market, or let's say you want to do the processing with respect to machine learning. Okay, so in that sense, there was we were facing the problem that we were not able to do the real time processing. Okay, now real time processing, if you want, let's say, so what real time processing is? Real time processing is that once you are getting the data, you are able to process it right away. Okay, not just that you are holding the data for some time and then you are processing it. Okay, so there are situations with respect to your stock market, your bank transactions, and other areas where you readily want to process the data. Okay, so that in that approach MapReduce was failing. Okay, because MapReduce के लिए you have to store the data in your HDFS first, क्योंकि MapReduce कहाँ से data उठाता है? आपके HDFS से ही उठाता है. If you remember, the source of the input file is always HDFS. Am I right or wrong?
Yes.
Right? So it is required that you should have your data in your HDFS. Okay, but let's say if your data is continuously flowing, in that scenario, you cannot readily store your data in HDFS and then apply MapReduce and do that, because it eventually will not apply a real-time analytics. Okay, you want that from one end your data is being captured and on the other hand it is being processed. Okay, so that's where your MapReduce was failing. Also, for real time processing you need a stream of data, and MapReduce जो processing करता है वो किस तरह की processing करता है? Can anyone tell me?
Parallel.
Yeah, it does parallel, but also one terminology is also used.
Ola.
It is doing batch processing, because your data is being captured in batches, because your data is segregated among the data nodes, right? So आपके batches में data pick होता है and then it is being processed. Okay, तो अगर बैच प्रोसेसिंग होगा तो उसके लिए रियल टाइम बैच प्रोसेसिंग के थ्रू हम रियल टाइम एनालिसिस नहीं कर सकते. Okay, so that is also one of the drawback we were facing with respect to MapReduce, right? Mm, yeah. Just give me 2 minutes. I'll.
You are not audible.
You were in mute.
Oh, oh, since when I was on mute? Guys, oh shit. Okay, okay, okay. Okay, fine. So basically, I just introduced you with these real-time analytics scenario. Okay, that banking sector where your transactions need to be processed quickly, okay, in order to do the fraud detection, right? Then your government sector, your cyber security also, if the government has to monitor the borders, okay, so they are basically need to process the satellite images or the drone images which are basically flying around your flying around your borders, so that in order to analyze any kind of intrusion they are facing or not, right? So that's also one of the area where real time analytics is required and data need to be processed at very fast speed. Okay, then healthcare is another sector which is, which was not initially being a part of this, but nowadays healthcare sector is also switching towards these analytics tools to basically, enhance the experience of their patients and also provide more facilities to them. Okay, telecommunication sector, your areas where, let's say, you have a locality where multiple towers are being placed. So, organizing the telecommunication company can basic telecom company can analyze that what is the load on particular tower, and is there a need to introduce more towers, or what is the network bandwidth load which is which on particular tower they are facing, how the interactions between the users or the connectivity between the users is maintained. Okay, so all these parameters. Then comes your stock market. So stock market is another sector which is basically generating data on high speed and also in volumes. So there also you need a engine which is able to process data at much faster speed. Okay, so these are the areas where your MapReduce basically fails. Okay, because the processing capability of MapReduce is not that up to that mark where these domains can work upon. Okay, these domains can analyze their data with. Okay, so also apart from these, your e-commerce websites, okay, your entertainment website, your Netflix, your Prime, and everything, they are all using Spark in some way in their backend. Okay, so that is what real-time analytics is. Then, what is Spark? So, Spark is an open source cluster computing framework for real-time data processing. Okay, so like your Hadoop, Spark also works in a cluster format. Okay, and the feature which makes Spark different from MapReduce is in-memory cluster computing. Okay, now what is in memory? In memory basically means in your RAM. Okay, so in Hadoop, or sorry, in MapReduce, what we were doing basically, जो processing हो रहा था, we were basically storing the data, and we were using the processing capability of MapReduce to do that. Okay, so प्रोसेसिंग जब भी हो रहा था मैपरेड्यूस में, सो आपने देखा होगा मैपरेड्यूस में जब आप प्रोग्राम एग्जीक्यूट करते हो तो आपने इनपुट डेटा ली, ठीक है, मैप फेज कंप्लीट होता है, मैप फेज के बाद जो आउटपुट जनरेट होता है इंटरमीडिएट की वैल्यू पेयर का, वो आपके वापस स्टोरेज में जाके स्टोर होता है। उस स्टोरेज से डेटा वापस रिड्यूसर पिक करता है, फिर उसको प्रोसेस करता है, एंड देन फाइनली योर final output is being again stored in the in the storage space. So there the storage space is extensively used. But Spark में क्या होता है? Spark क्या करता है? एक बार आपका डेटा उठाया, उसको अपनी मेमोरी में रखता है, प्रोसेस तब तक उसको करता है जब तक कंप्लीट आपका जो प्रोसेस साइकिल है वो कंप्लीट नहीं होता, तब तक वो उसे मेमोरी में रखेगा। And once the process is being complete, then the final output is being stored in the storage space. तो क्या बार बार इंटरैक्शन आपको स्टोरेज स्पेस से नहीं करना पड़ रहा है, एक बार मेमोरी में आ गया हो तो प्रोसेसिंग आपका डेटा जो भी उसको पिक करना है वो मेमोरी से उठा लेगा। तो इफ यू सी दैट ऑलरेडी आपका जो टाइम कंज्यूम हो रहा है स्टोरेज स्पेस से इंटरैक्शन का वो कम हो गया। गॉट द पॉइंट? ये चीज समझ में आया सबको? यस और नो? यस और नो एवरीवन?
Yes, ma'am.
ठीक है, ओके। Then Spark provides an interface for programming entire cluster with implicit data parallelism and fault tolerance. So Spark जो प्रोग्रामिंग एनवायरनमेंट है वो entire cluster with implicit data parallelism. Again, the data parallelism जो processing है वो parallel format में ही हो रहा है, okay, and also it is also maintaining the fault tolerance. We'll discuss that how fault tolerance is being taken up, okay, by Spark. It is based on Hadoop. Okay, so basically the basis on which Spark is designed is Hadoop only. Okay, so you can say that whatever shortcomings we were facing with respect to uh, um, MapReduce, now we tried to overcome them through Spark. Okay, so that is what the aim is. Okay, and based on Hadoop is because Spark का खुद का कोई स्टोरेज इंजन नहीं होता. ठीक है. जैसे हडूप में तो क्या था कि आपके पास HDFS है और उसके पास मैप रिड्यूस प्रोसेसिंग करने के लिए आपके पास मैप रिड्यूस है. बट इन स्पार्क व्हाट हैपेंस इज स्पार्क का अपना सिर्फ प्रोसेसिंग इंजन होता है. ठीक है. तो स्पार्क क्या करता है, आपके या तो HDFS की स्टोरेज स्पेस से उठाएगा, या अगर आपने स्पार्क किसी और स्टोरेज स्पेस के साथ इंक्लूड करके इंस्टॉल किया हुआ है, जो लेट्स से कि आप अपने स्पार्क इंडिपेंडेंटली अपने लैपटॉप पे स्टोर किया है, तो स्पार्क what it will do, it will take the storage space of your laptop and then do the processing of the data. Okay, so Spark is just basically a processing engine. ठीक है, तो उसे स्टोरेज से डेटा पिक करने के लिए स्टोरेज स्पेस कोई दूसरा होना चाहिए. तो आप या तो हडूप में HDFS के थ्रू कर सकते हैं. आप लेट्स से आप अगर स्टैंड अलोन बना रहे हैं तो आप किसी लाइनिक्स सिस्टम पे या आपके विंडोज सिस्टम पे कर सकते हैं. ठीक है. So there are multiple ways you can use Spark. Okay. It support languages. So आपने देखा होगा MapReduce के साथ हमारे पास constraint था कि majorly we were doing the programming in Java. Okay. Now, if a person who is not proficient in Java, not proficient in Java, so will he so that will that mean that he has to learn Java, or he will not be able to process it, or he has to hire some person who is proficient in Java to process the data. Okay, so there is always a dependency involved. Okay, but with Spark, what we tried to do is that we made Spark in such a way that it's a polyglot. Now, polyglot basically means that it supports multiple languages. You can program in Scala, you can program in Python, you can program in R, you can program in Java. Okay, so multiple language support. So whatever language you are comfortable in, or the person who is processing the data is comfortable in, they can use that particular language and can process their data. It provides 100 times faster performance with respect to your MapReduce. So 100 times faster performance is because we are doing this in memory processing. Okay, we are no more having multiple interactions with the storage area. So that is the reason we are 100 times faster in processing than MapReduce. Okay, then why Spark when Hadoop is already there? So I gave you the answer that with Hadoop, basically what is happening is that over the period of time we are processing the data. Okay, so basically the data is stored in the HDFS and it is processed afterwards. Okay, so there is a time lag between processing of the data. It is not being done readily. Guys, I have not asked for the attendance. Don't worry. Okay. Just focus on what I'm um, telling you. Okay. Yeah. So, uh, so we are facing time lag. Okay. So it is not that we are readily processing the data. So Hadoop process the data stored over a period of time. So data is stored for a period of time and then it is being processed. Okay. So there is a time lag we are facing with respect to Hadoop. But with respect to Spark, we're doing the real time processing. Okay. As soon as the data is being captured, we are processing it. So there is no time lag. So Spark overcomes the time lag issue. Okay. So this is the main difference between your Hadoop MapReduce and Spark. Okay. Now, if we compare Hadoop, Hadoop and Spark, so processing data using MapReduce and Hadoop is slow. So it is comparatively very slow. I told you the reason that it is slow because we are basically interacting with the storage space continuously. Okay, we are completing the map phase, then we are interacting with storage space. Then we are completing the reduced space, then again storage space is interacted with. Okay, so there are multiple interactions, multiple read write operations being carried out. Okay, so that's why the processing is slow. With respect to Spark, it is 100 times faster as compared to MapReduce. Okay, because we are doing the in-memory processing. Once we are picking the data from the storage space, keeping it in the memory and processing it there only. Okay, performs batch processing of data. Okay, so here हम batches में data को process कर रहे हैं. यहाँ पे स्पार्क में हम both batch processing भी कर सकते हैं और हम real time processing भी कर सकते हैं. ओके, रियल टाइम मतलब कि आपका स्ट्रीम्स में डेटा आ रहा है उसको हम प्रोसेस कर सकते हैं. ठीक है, स्ट्रीमिंग डेटा हम मैपरेड्यूस के केस में नहीं कर सकते हैं. ठीक है, देन Hadoop has more line of code since written in Java. Okay, so if you have done your MapReduce program, तो word count के लिए हमने कितनी lines of code लिखा था? Can anyone tell me? Yes, तुमने किया था ना word count का program? So how many lines of code we have written for the word count program? Okay. I know few of you have not done because few of you have just got the concept of MapReduce. So with MapReduce programming, the lines of code are huge. Okay, so for simple word count program, we are basically doing 100 lines of code. Okay, but with respect to Spark, with respect to Spark, there are fewer lines of code. Why fewer lines of code? Because we can write code in Scala, which is much concise with respect to Java. ठीक है, Scala जो है आपका Java का ही एक आप extension मान सकते हैं, and it is much more concise. Lines of code बहुत छोटे होते हैं Scala में. आप अगर Python में Spark programming कर रहे हो तो भी आप बहुत कम लाइंस में आप काफी फंक्शनैलिटीज इनकोड कर सकते हैं. ठीक है, सो with Spark we have fewer lines of codes. Does not support caching of data. Okay, so let's say if you want to store a particular stage of your processing. Okay, let's say आप MapReduce programming कर रहे हैं and MapReduce में अपने map phase के बाद का जो intermediate की वैल्यू पेयर है आपको वो अगर कहीं स्टोर करके रखना है. ठीक है, यू वांट दैट कि आप उसको कहीं अपने अपने आर्काइव की तरह आप उसे स्टोर करके रखें सो दैट फॉर एनी फ्यूचर रेफरेंसेस और फॉर एनी फ्यूचर यूज यू कैन यूज दैट पर्टिकुलर स्टेज ऑफ डेटा. ओके, तो वो पॉसिबल नहीं है आपके मैपरेड्यूस के केस में. दो क्योंकि दो जो इंटरमीडिएट डेटा है वो स्टोर जरूर होता है एचडीएफएस में स्टोरेज स्पेस में जाके, बट वो कहाँ होता है लोकेशन इज नॉट, यू कैन नॉट लोकेट दैट लोकेशन, राइट? तो caching of the data is not possible with respect to MapReduce. Okay, but with respect to your Spark, you can cache data. Okay, cache basically you can store a particular stage of your processing. Okay, and that stage you can use for further uses, let's say for any other program or for any other use, for any other documentation or something, you can do that, right? So these are some basic differences. Okay. Limitations of MapReduce. MapReduce is not a good choice for real-time processing that we have discussed. Not suitable for writing trivial operations like filter and joins. Okay, so you cannot perform any kind of join operation. Okay, so let's say if you have a tabular data or you want to perform certain kind of joins between two tables or something, you cannot do that. MapReduce doesn't work well with large data on a network. So if you have a huge amount of data set on network, basically it's it's like that your data is being stored on network and you need to capture it in real time and you want to process it, that you cannot do. Unsuitable for OLTP, which includes a large number of short transactions. Okay, so like for example, banking transactions. Okay, there are large number of short transactions which are happening simultaneously. Okay, so for that kind of processes, again, MapReduce is not a good choice. MapReduce is unfit for processing graphs. So these graphs which are mentioned here now, these are not those your bar charts or your histograms or your pie charts. Okay, these are not those graphs. These graphs are basically your graph database. Okay, so if you are aware, I'll tell you. These are your graph databases. Okay, where you have certain, another example, yeah, these are type of graph databases. Okay, and these databases are basically related to your social media. Okay, now in social media domain, your data is being stored in such format. There is a person who's having multiple friends, what kind of activity he's doing, what infrastructure, what processes, everything, what likes, dislikes, comments, posts, tags a particular person is doing. All these kind of things are being stored in a graphical format. Okay, so these are graph databases. Okay, likewise, your social media stores your data. Okay, with where you have the element and there is the vertices represents the relationship between the elements. Okay, so if you have such kind of data, then um, MapReduce is not suitable. Okay, so these are the limitations for your MapReduce. Features of a Spark. So it is fault tolerant. Okay, if any kind of uh, fault occurs. Now what this fault is, let's say कि आपने कोई process किया, ओके आप कोई फाइल को प्रोसेस कर रहे हो और उस प्रोसेस को करते टाइम लेट्स से फाइल प्रोसेसिंग कंप्लीट होने से पहले ही आपका प्रोसेस हॉल्ट हो जाता है. ठीक है, सो इन स्पार्क वी हैव दिस फैसिलिटी दैट वी कैन locate that last stage before the halt. Okay, halt से पहले की जो स्टेज थी उसको हम आइडेंटिफाई कर सकते हैं एंड हम दोबारा जो प्रोसेसिंग है हम उसी स्टेज से स्टार्ट कर सकते हैं. MapReduce में ऐसा नहीं था. अगर आपका एक प्रोग्राम फेल होता है तो आप अगेन वापस से है ना स्टार्टिंग से रीस्टार्ट करना पड़ता है, स्टार्टिंग से एग्जीक्यूशन करना पड़ेगा. उसी पॉइंट से दोबारा एग्जीक्यूशन नहीं स्टार्ट कर सकते. ठीक है, सो दिस इज द व्हाट द फॉल्ट टॉलरेंस इज. रीयूजेबिलिटी, क्योंकि हम डेटा कैश कर सकते हैं. ठीक है, आप पर्टिकुलर स्टेज को कैश कर सकते हो प्रोसेसिंग की, तो आप उसे रीयूज कर सकते हो. सो देयर इज अ रीयूजेबिलिटी फैक्टर. Dynamic in nature, why? Because you can perform batch processing as well and real time processing as well. स्पीड, स्पीड क्यों है? क्योंकि हम इन मेमोरी प्रोसेसिंग कर रहे हैं, 100 टाइम्स फास्टर प्रोसेसिंग हमें कैपेबिलिटीज मिल रहे हैं उसकी वजह से. लेजी इवैल्यूएशन, अब देखो हम बात कर रहे हैं यहाँ पे कि फास्ट स्पीड में हमारा डेटा प्रोसेस हो रहा है, 100 टाइम्स फास्टर है, बट अगेन वी आर ऑल्सो यूजिंग द टर्म एज लेजी इवैल्यूएशन. नाउ व्हाई दिस लेजी इवैल्यूएशन इज, लेजी इवैल्यूएशन टर्म आती है स्पार्क में एक कंपोनेंट होता है RDD. RDD, resilient distributed data set. Okay, these are your basic units of processing any kind of data in Spark. Okay, ये आपके बेसिक यूनिट्स होते हैं RDDs. तो RDDs की जो प्रोसेसिंग होती है वो लेजीली होती है. ठीक है, विल अंडरस्टैंड कि RDDs लेजीली इवैल्यूएट क्यों होते हैं और अगर लेजीली इवैल्यूएट होते हैं then how they are still faster. Okay, so we'll understand that later, right? एडवांस एनालिटिक्स के आप मशीन लर्निंग अप्लाई कर सकते हो, आप ग्राफ डेटाबेसेस को प्रोसेस कर सकते हो. दैट्स वेयर योर एडवांस एनालिटिक्स कम्स इन मेमोरी कंप्यूटिंग. आप रैम में कंप्यूटिंग कर रहे हो, दैट इज ऑल्सो अ वेरी क्रूशियल फीचर. बिकॉज ऑफ दैट यू आर गेनिंग द processing speed. Real time stream processing, okay, whatever real time data you are getting, you can process it. Okay, so Spark streaming is is one domain where you can process streams of data, okay, on real time. Okay, so that is one of the features of your Spark. Again, okay, these are the components of your Spark. So you have Spark Core, you have Spark SQL, Spark Streaming, Spark, ML libraries, and graphics. So graphics is the component which works upon your graph databases. ML library is the component which works on your machine learning set. Okay, so if you want to do a particular machine learning over your data, you can use this component. Spark streaming. Okay, you have streams of your data which is continuously flowing. Okay, you need to process that type of data. Then you can use Spark streaming. इसका बहुत अच्छा एग्जाम्पल मैं आपको बताती हूँ. अभी T20 चल रहा है, ठीक है. T20 में आपने देखा होगा, आपको फिगर्स बहुत जल्दी जल्दी फ्लैश होते हैं स्क्रीन पे, ठीक है. वो कैसे होते हैं? आपको लाइव स्ट्रीम चल रहा है आपके मैच का, ठीक है. डेटा इज बीइंग जनरेटेड कंटिन्यूअसली कि कौन सी बॉल कितने स्पीड पे कि what was the pace actually. Sorry, I'm sorry with my terminology with respect to cricket. Okay, I'm not a fan of cricket, so I'm trying to give you an example just. Okay, so just bear with the terminologies if I'm wrong somewhere. Okay, सो लाइक कौन सी बॉल किस स्पीड पे डाली बॉलर ने, या रन रेट क्या चल रहा है, और क्या टर्म्स होते हैं, लाइक ओके, हाउ मेनी बॉल्स, व्हाट शुड बी द rate, in how many balls you should the target should be achieved and everything. Okay, what is the strike rate of the batsman, and such kind of things. Okay, so all these data is being generated. Okay, so what happens is there is an engine involved in backend, or इस process के लिए भी there are companies which are using Spark to process such kind of data. ओके, तो हो सकता है लेट्स से आप कौन सा ऑन स्टार स्पोर्ट्स या जो भी है, जिस पे भी वो स्ट्रीम हो रहा है, मे बी इन द बैक एंड दे आर यूजिंग स्पार्क. ओके, सो हो क्या रहा है, स्ट्रीमिंग हो रही है डेटा की, एंड दे आर कॉन्टिन्यूसली evaluating the data which is being generated, and based on that they are giving you stats, or the stats are being flashed on your screen with respect to the current match, right? So likewise you can process the data with Spark SQL. So let's say if you have a tabular type of a structured data you are having, okay, so आप SQL Spark SQL के थ्रू आप SQL की फॉर्मेट में अपने डेटा को प्रोसेस कर सकते हो. विद हेल्प ऑफ एसक्यूएल, स्ट्रक्चर्ड क्वेरी लैंग्वेज, यू कैन प्रोसेस योर डेटा. ओके, एंड स्पार्क विल assist you in doing that, right? Will give you a faster processing capability. Spark core is the core in on top of which all these four elements components are working. Okay, so we'll be discussing these components one by one now. I hope till now everything is clear to you all. Yes, everyone.
Yes. Yes, ma'am.
Okay, any queries so far? Yes, any queries? No? Hmm. Okay. So what is Spark Core is? Spark Core is based is the base for large scale distributed and parallel data processing. So basically whatever kind of processing you are doing over your data, उसके ऊपर distributed and parallel data processing apply करने का काम आपका Spark Core का ही है. Okay, it holds the components of scheduling, distributing and monitoring of the jobs. So see, यहाँ पे Spark Core जो है, it is also responsible for your scheduling of your data, scheduling of your job, distributing it across the cluster, and also doing the monitoring of it. Okay, so that's where your Spark Core is a crucial component of it. Okay, over all over your Spark Core, all other your Spark SQL, streaming, ML libraries, and graph are basically uh, working on. Okay, does task dispatching and fault recovery. So if any kind of fault we are having, your Spark Core is handling that. Task dispatching basically means that what task is need to be dispatched to which data node that is being or data node or the worker node that is being done by your Spark Core. Home to APIs that define RDDs. So basically, Spark Core holds the APIs which are basically looking after your RDDs. Okay, now RDDs are resilient distributed data sets. These RDDs are, you can say, your the basic units of your processing. Okay, basic units mean that, let's say, whatever data you have captured, okay, now what processing you will be applying over that. Okay, so the chunks of these RDDs are being created so that processing is being carried out smoothly. Okay, RDDs perform two operations. Okay, so for a particular RDD, there are two operations which are there. One is transformation, and the other one is the action. Okay, we'll understand what is this transformation and action is, but you for now you can say that RDD is having two operations, and RDDs are the basic units of your processing with respect to Spark. Okay, we'll see in detail that how these RDDs are basically functioning. Okay, and why these RDDs are being called as lazily evaluation. Okay, so we'll see these terminologies as we move ahead. Okay, so Spark Core, we got the understanding that how Spark Core is basically a component which is doing with which is dealing with all the scheduling and dispatching and everything fault patterns, right? Then comes your Spark SQL. Spark SQL. So Spark SQL lets you query structured data. So let's say if you are dealing with a structured data, it's not always that big data is always in the form of just your unstructured or structured and semi-structured combination. It can be a structured data, but if the volume is so high that you cannot process it through your traditional databases, so you need a mechanism to process your data. Okay, so in that way, Spark SQL is another tool you have to process your structured data. Okay, can load and query data from different data sources. Okay, so for Spark, you can load a data and you can query data from different sources. Now the data source can be multiple. Okay, uh, then use same engine for both interactive and long queries. So there is only one engine. It's not like that for interactive one you have a separate um, engine to do that. And long queries at the same time, it's not like that you have to have only you know short queries that will be processed. You can process long queries. Okay. Then uh, it contains three layers. So there are three layers which are present. One is the language APIs, then you have schema RDDs, and then you have data sources. So language APIs, that means that you have support. Let's say you have Spark SQL with you, and you have support of multiple languages like Python, Java, Scala, R. Okay, Hive HQL as well. Okay, so from that also you get the support of the language APIs. Then schema RDDs. So schema RDDs are basically you can say Spark core is designed with, yes, someone saying something. Okay. So basically, schema RDDs, as you know, that's Spark SQL, since we are working over structured data, so works on schemas, tables, and records. Okay. So therefore, we can use schema RDDs as a temporary table, and we can call this schema RDDs as data frames. Okay. So that's where your schema RDDs can work. Then comes your data source. So there can be multiple data sources. I told you, your data source can be your Cassandra database. You can have JSON documents. You can have Hive tables. Okay, all these can be your data sources. Okay, so there are multiple data sources which are being supported. Okay, so on also one of the benefit is that, let's say if a person who's very much familiar has worked for 10 to 10 to 15 years in RDBMSs. Okay. And all of a sudden he has to, process the data with respect to Spark. Okay. So there also this Spark SQL is helpful because you don't need to have to learn some other language readily. Okay, Spark SQL will automatically, or you can say will has an environment which can support your SQL queries. Okay, support the processing of your structured data. Okay, then the another component is your Spark streaming. Okay, so Spark streaming, machine learning libraries, graphics, and other things we'll be discussing in tomorrow's session. So, okay, we'll continue all this in tomorrow's session, right? So tomorrow we'll be having the session at the same time, 3 to 4. Okay, so I hope today whatever we have gone through so far, I hope you are able to understand these things.
What is JDBC and ODBC?
See, JDBC or this
ODBC.
yeah, ODBC your what you can say your um the
Object
just
database.
just a second. Sorry, just a
Ob-
second, please.
Object database connector or something, and Java database connector or something. Open based activity.
Just a second, please. Hold on for a minute.
Open database activities.
Yeah. So your Java JDBC is your Java database connectivity, and or ODBC is your open database connectivity. So open database connectivity is this. It's basically, you know, it's an interface between the accessing of your data and everything. Okay, so in it's an interaction, or you can say an interaction which is being established between your database systems and your operating systems. Okay, that is where your ODBC works in. Okay, and your JDBC is your uh, interface which basically enables you communicate between your database management system and your application. Okay, तो ODBC आपके OS और database system के बीच में connectivity, and JDBC is your application और आपके database के बीच में connectivity is being established between is being established through these things, right? सो अगर इस तरह से आपका कोई ना स्टैंडर्ड कनेक्टिविटी है डेटाबेसेस के साथ, तो देयर आल्सो यू कैन यूज दिस स्पार्क एसक्यूएल. ओके, सो ओके, क्लियर दैट.
Yes.
Yes.
Thank you.
Yeah. Okay. Yeah. And anything else? Anything else you want to ask? Yes. No other queries from you guys? Okay.
Can you share the slide today itself so that I can go through once more?
Okay, fine. I'll share them. Or you can, if it is possible, you can wait for, let's say, tomorrow. I'll share the complete PPT
Sure.
tomorrow itself only.
Yeah, yeah, sure.
Yeah. So that will be a complete chunk of the data with you will be having. Okay. Otherwise, it will be in parts, right? So okay. So
That's fine,
okay.
man. Yeah.
Okay, fine. So okay, guys. So we'll be meeting tomorrow at the same time, 3 p.m. I hope today I'll not face any kind of technical glitch. Okay. So thank you, everyone. And we'll meet again tomorrow at the same time. You can give your attendance in the chat box so that I can mark it. Okay. What you have not done, please do it so that I can just mark it. Take just 5 minutes and you can post it.
Yes, ma'am.
Those who have done, they can leave. Okay.
I'm unable to give my attendance, ma'am.